but Rafał, come on here because I'm going to introduce you because we speak together today. So it's great to see you all. I can see some familiar faces because I remember talking to you yesterday, some of you. And today we're going to talk about automatic gameplay testing with AI, and we're going to think if it's actually finally possible. So my name is Alina Powała, and my experience is actually in building analytics products. But my background is in computer science, and then I did PhD in artificial intelligence. And at our company, QED Software, we are experts in AIs, and I help the company to translate the benefits of our technology and an AI to our customers. So I care about the product that we create.
And I am a tech guy. I have 7+ years of experience in game dev. Most of this is in AI. First I started in simulation games and traffic simulation for simulation games. And now I work for QED Software as head of AI development. And I'm a co-creator of Grail AI framework. And now I'm going to take a seat.
But not for long, because then, you have the most interesting part to talk about. Okay, so what are we going to talk about today? First, why? Because we have to have good motivation to do anything. Then a bit of how, and this is some of inspiration from QA for software engineering. Then why not, maybe, because QA for software engineering is, I guess, much different than QA for game development, and we'll see what are the similarities and what are the differences. Then the fourth point is all Rafał's, and it's actually what can be done in game dev, and then we'll sum up. All right, so here is our motivation. What if, I want you to just dream of what you would really wish that was possible in QA for game development. So what if we could make human testing less mundane? What if we could start testing really early? What if we had really good game testing standards? And so on and so forth, repeatability, test game balancing, well, automated testing and play testing analytics. And these are some of the wishes also expressed in that paper by Politowski, a survey of video game testing. I'm going to come back to the paper later on. So it's all about, us visualizing the future, because right now we know what is possible today, but we do not really know what's possible in the future. And even if you're an expert in the field, your predictions about the future can be really off, like Thomas Watson once thought that there is a world market just for 5 computers, where actually it's not, and he was the president of IBM. So I'm just trying to send the message that if we are at a place where breakthrough in research enables us to reach for something that was not before available, maybe it's worth it. And let's see if actually it is worth it. So there are stories on internet that people are hiring testers. So this is from February and from April this year. And I believe these 2 stories and more other such stories send some sort of a signal to the game tester market. So they're hiring testers, not for some gigs or some contract jobs, but full-time employees with pay bumps. And that's an investment. So that's statistics from Glassdoor. So this is USA's median wage, yearly median wage of game tester, or QA video game tester, and it's around $56,000. So again, if we make an educated guess about the future, and if we could imagine what if we could make like half of the time of that person, the repetitive stuff that they do, if we could automate them, we could save, and it's not savings that go outside of the company, but they are actually invested for the improving of the quality of the product. But we could save around $30,000 a year a person, and with a star, because you have to multiply that by the size of the QA team, and then subtract the cost of implementing and maintaining that automation. And that cost varies because different company sizes or companies that produce different type of games have different, let's say, structure. So maybe smaller companies, smaller game studios, the percentage of testing, maybe it's higher, and probably in the bigger productions, the percentage of how much QA testers they have is lower. But altogether, that number might still be very big, right? So you, in your own head and heart, have to decide whether that actually makes sense for you, whether it's worth the money. But money is not the only motivation here. So I'm referring to the same paper, which is actually very interesting. So if you haven't read that, it's available online, so you can reach out to that. And they have several postmortems there from the companies that they surveyed. So one of the postmortems, they say, the arena bug was subtle, although the results were not, and it was not easy to reproduce. We were dimly aware that the bug existed, but its frequency was unclear. Because of the difficulty in reproducing it, the scope of testing, the rest of the game, and the small size of the QA team, the bug was not properly identified. So that means that the game went into production with a bug that they know existed, but it was not identified because they didn't have either resources or it was just very difficult to identify it with the resources they had. So the second motivator for you is the quality. So if your game testers could not do all repeatable, repetitive stuff, they could really maybe focus on such bugs that are impossible to find by automation tool. And the overall quality of the product is improved. Another postmortem from the same paper. In order to fully test all the variables we had in place, it would have taken hundreds of testers, several days of extensive playtime to fully debug this game. There were bugs that actually took 100,000 plus people 4 weeks to find due to how buried and rare some of them were. And that tells us about the time. So time is also a very big motivator because sometimes time is everything. If you miss the spot, if you miss the timing, you might be really in a bad position in the market. So depending on which generation you're from, if you're a baby boomer or millennial or Gen Z, you would probably treat all those motivators differently. So money, who cares about money, right? The time is everything we have. But on the other hand, time is also money. So that's for your consideration, these three factors. So is it worth it? I guess you know that cost of fixing bugs is really low at the beginning, at the requirements and design stage, and can skyrocket later on when you have user acceptance tests at operation. And automated testing, Roy, follows a similar pattern in everywhere where you can see such charts. So sometimes that x-axis is a bit closer to 0, sometimes, the intersection point. Sometimes the x-axis is different, but overall we have all the time the same chart. So at first you make a small investment, and then you get the price at some point in the end. So how? What's quality assurance and what's quality control? So quality control is one small part of quality assurance. It's responsible for software testing. So it's the testing team. It's responsible for the product quality. But quality assurance is all the things that team does collaboratively, collectively, to prevent the bugs from occurring. Now, just a few words about testing types, really QA basics, because we have functional tests, non-functional tests, change-related tests, and we have test levels. So we need to test individual components, and for this purpose, we write unit tests. And if you think, why not? Well, you have to write unit tests for your colleagues, because when they are going to update your code without unit tests, they really don't know what to do. And then we have testing component groups. So these are integration tests. And for the integration tests, there are so many memes on the internet. I just took this one. So you have 2 unit tests, but 0 integration tests. So that happens in my house as well. And I really prefer if people thought about integrating stuff before they put it into production. And then you have system tests and acceptance tests. And all those test levels, different people play a leading role. So first, you have developers who write unit tests. Then integration tests are written by developers and testers. Then come the testers, and then come the business. And now challenges. Okay, so that's a very small survey of just 7 game studios. But how do we actually test in game dev? And here I really wish that you could maybe later on also talk to us about how you do the testing, what's important in your case, because that would be really interesting for us. Now I'm going to talk just about these two aspects, so main testing objective and use test methods. When it comes to main testing objectives, the survey respondents here were supposed to rank 3 aspects, so technical aspects, user experience, and game mechanics. And surprisingly for me, the technical aspects won here. So every company stated that they do some technical aspect testing. When it comes to test methods, however, the usability testing, so that's what we all think it's actually the most important in game dev, won with 4 gold medals. And however, the explorative testing, the thing that we're going to talk to you about today, was in total had the same number of companies saying that they perform it, right? So 5 out of 7. So that's common. I mean, that 5 out of 7, it's a common problem for companies to do explorative tests. So now a small video to show you how, in large speed, how we can do explorative tests in our game. So here the tester or the designer just selects or changes the path, the way the artificial intelligence bots are going to follow. And you can see that they are going to walk around that lake, and not only walk, but they also engage in, in encounters with the enemies. And the goal is to walk around the lake and meet at the end. And having, several such scenarios, we could test if a level is actually playable, if you can reach the end without dying, and at the same time engage in a meaningful way with the enemies, not just walk around the lake and like it. So here they actually died, but that next thing is going to be really interesting, and it's going to be Rafał Tyl.
Right. So now I'm going to show you some videos of stuff that we tried in our company, because we, as QED Software, we are a game AI company, like the part that we hired in, and we realized that okay, we can do AI, so maybe we can reuse the thing that we do anyway to test our games. And so, what do we need to perform automatic exploratory tests? We need semi-competent AI bots. They don't have to be of such high quality as production bots, because no one will watch them. They just need to be able to move around the level and perform and interact with the world using the most basic game mechanics. They have to be easy to reparameterize, because if you want to create many testing scenarios, you don't want your testers to like rework the whole code of the bot. You want some easy configuration that could produce different behaviors. For more complex scenarios, you would prefer goal-driven approaches rather than reactive approaches, such as behavior trees or maybe utility AI. You would rather prefer some GOP or maybe simulation-based techniques. And you need a way to reproduce those bugs, because, okay, you can get a log that some error occurred, but you need to somehow reproduce. Okay, now I'll skip this slide because we don't have enough time. So the ideal scenario for automatic testing is just dropping the bot, a preset bot on a level, specifying a goal for the bot, leaving it to run for a minute or for half a minute, depending on the scenario, and in the meantime, checking all your assertions periodically. In case of an error, of course, logging the reproduction, etc. And now I'm going to show you some real examples that we've tested in our company. First is a small toy example of a simple game, a very simple game. Then I'll show you a real world example of a game that we shipped, and later I'll focus on testing in pre-production, in early stages of game production. So here we see an agent that's configured using utility AI. And the basics of the game is that the agent just walks around and picks up collectibles. In no particular order, just walks around from pickable to pickable. And then, using a graphical tool, which is easy to do using the technique, you just reconfigure maybe I'll speed this up. You just create a duplicate configuration of the bot and change the preferences using a utility curve, like this. So here we specified that the bot should focus on collectibles that are in mid-value range. And the value is marked as the pickable size on the level. And so the reconfiguration is just like this. You just specify a curve, save this all, reload it, and you have another test scenario. So you can test the same level in many different ways using a few preset AI configurations. So onto the specifics of how you do it in utility AI. It's a technique that lets you easily transition from the semantic or high-level concept description to a configuration, because here you can see some sentences in English, and to the right you can see the same description being translated to a configuration of utility AI, and basically it's you could call it a sentence in fuzzy logic. And on the bottom here you get the evaluation of a given behavior given some considerations that are defined higher, for example health, when picking up a medkit. And this is a concept of low health. You just get a health consideration, it passes through a mathematical curve that defines what does it mean for us that the health is low. And now onto a more complex example, more complicated one. Recently we shipped a game called Tactical Troops, and it's a tactical game. It's a tactical game, turn-based, but on a continuous space without a grid. And for this game, we had to implement skirmish bots that the player could engage in and that would be challenging. So it was a lot of work to create, like, maybe not ideally human-like, but like high-performing bots that could cooperate, that could work together towards a common goal. As you can see, the blue team is dividing the team into sections. Two of them are concentrated on the center of the map, etc. And the other ones are trying to, for example, take control points. And given that we've already put so much effort into implementing those bots, we thought that, okay, they pretty much play like real human players, so maybe we could reuse them to simulate human players. And this is the basic overview of the bot architecture. It's really, really high level. I'm not going into any details here. So it consists of 3 layers: strategic, tactical, and unit AIs. And thanks to the architecture that we used, that's Blackboard-based, for example, the tactical entity doesn't require any specific implementation of the strategic AI of the higher level. They just communicate through a Blackboard via a specific communication protocol. So we could just swap the strategic entity with our custom goal selector used for testing, and then leave the bottom layers just as they were. And here you can see, this is a similar video that Alina showed you before. So the big red and blue dots that you can see on the level are the goals specified by a designer. So this layer that you could see before, this topmost layer, is replaced. We replaced the strategic AI with a simple predefined paths on the level. And as you can see, thanks to the fact that we can reuse the lower intelligent layers of the agent, they still exhibit intelligent behavior, but it is driven by the goals provided by a designer or by a test engineer. Okay. Next, please. And then we onto the hardest part, because this, the thing that I'm going to show you now is very specific for our game, and you would have to build something like this for yourself. It's not easily like reusable between productions, and namely bug reproductions. So we used a login system to produce like full replays of the game state. For example, we could just make the bots fight each other, then get the log from the game, the full log of game states from the game, and put it in a simple replay app, a custom replay app that we built specifically for this game. And as you can see on the timeline, you can see any important events like character deaths or any shot actions or explosions, etc. And you can provide your programmers with such replays, coupled with, for example, like stack traces of any bugs that are encountered, and the programmer or your developer can simply scroll through the gameplay log and see what really happened on the map. So you may think that it is very that it may be time-consuming and very costly to build such a replay app, but actually, if you because in our replay app we have full graphics, we can see everything in nearly as it was in the true game, but really you can replace it all with simple circles and polygons and squares, and it's not, believe me, it's not so time-consuming to build such a replay app and a logger for gameplay states. So it will cost you some time, it will cost you some money at the start of your production, but it will really make it much, much easier in the future to see what actually happened in those automatic tests. So, okay, so this was a fully developed game when we even started producing such automatic tests. But what if you're just starting out and you don't even think about implementing AI, or maybe you have some very, very rudimentary behavior implemented. So first, you don't have to have a fully fledged AI to test your game, because you want to just, at the start of the game, you want to, at the start of the production, you just want to test simple game mechanics. You want your bots to run around the level, or pull levers, or push around some boxes, and you want to check, for example, for any null references or any obvious bugs that you may encounter. So just start away with very basic behaviors, and don't care. You shouldn't care right from the start about any intelligent decision making. Just make it random or semi-random or something like this. But make sure right from the start that the AI code is modular, so that you can reuse those behaviors that you've written for your testing AI, that you can easily take it and reuse it for your in-game AI. So this should be the focus right from the start. Make sure your AI programmers care about reusability and modularity of the AI. So here's a simple, a short video of a game that we are currently developing. It's in early pre-production. As you can see, we have some level. There are some basic objects on the level, and there are preset AI agents on the level, and they just run around. This guy just walks around crouching behind covers, so we can check if the covering mechanic works properly. Another one is walking just back and forth. Another one is looking right and left. And this is everything that you need. It runs in Unity here in this presentation in their native test framework, and you can set up such tests in your CI pipeline or anywhere you want. Okay, so what are the key takeaways? No? Yeah.
All right, so actually I'd like to ask you, what are your key takeaways from our side? It's just a message that, you know, game QA is different, but we can take some inspirations from QA in software development, and there are some tools, and the right tools can help you with the automation of those exploratory tests, as Rafał just showed us how much automation we are able to do. And that it can even start at the pre-production phase. So that's actually something I believe interesting, that can start so early. But then you have to, you know, decide for yourself if it's worth your time. So, you know, thank you. This is part of the project that Rafał is working on right now, and you know where to find us. We're at the B2 if you want to talk with us a bit more. But that's it for now. I don't know if you have time for questions or not.
Yes, we have a small period of time for one or maybe two questions, if someone have. Okay.
Hello, I would like to ask a question about the maintainability of the tests. How often you have to update them, and what about the cost of updating them and managing them?
Well, you have to update the AI as soon as some very, very deep core mechanic changes. For example, if you have a walking behavior or some game level interaction, if those core mechanics change, yes, then you have to update the behavior code. But as soon as you have your core mechanics in place, for example, you have your walking, interactions, shooting, using abilities, then it's very easy to maintain because you don't change the basics of the code. For example, in our game, it's a tactical game, like the commands of walking from place to place or for performing an ability are very straightforward. But as new abilities emerge, you just add a piece of the code responsible for this specific ability. So you don't have to you wouldn't have to put more work into it than you put into your normal unit tests or integration tests.
Okay, thank you very much.